Hi, in this session we will discuss about signal flow graph algebra. So, first rule is incoming signal to a node through a branch is given by the product of a signal at previous node and the gain of the branch. That is first rule. An example of this rule is shown in the figure. That is, there are two nodes. The nodes are marked as x1 and x2. And this transmitter is marked on the line connecting x1 and s2 as A. There is an arrow mark that represents the signal flow. So in this case, x2 is the output node and x1 is the source node. So we can write x2 will be equal to A into x1. So the incoming signal to a node through a branch is given by the product of the signals at that node and the gain of the branch. So here x2 is equal to the gain A into incoming signal x1, okay, and same we can see x1, x2, x3 are the three nodes and A1 and A2 are the transmittance. Then we can write x3 will be equal to A1 x1 plus A2 x2. So second rule is cascaded branches can be combined to give a single branch whose transmittance is equal to the product of the individual branch transmittance. Here three nodes are given x1, x2 and x3 and its transmittance is there are two branches and transmittance are A and B, then it can be combined to give AB. So the cascaded branches can be combined to give a single branch whose transmittance is equal to the product of the individual branch transmittance. And next rule number 3. Parallel branches may be represented by a single branch whose transmittance is the sum of individual branch transmittance. So there are two nodes and these are parallel. Branch connecting between two nodes are parallel and each branch has a transmittance A and B. Then it can be represented by a single branch having transmittance A plus B. So parallel branches may be represented by a single branch whose transmittance is the sum of individual branch transmittance. Next is rule number 4. A mixed node can be eliminated by multiplying the transmittance of outgoing branches to the transmittance of all the incoming branches to the mixed node. So it is shown that there are four nodes x1, x2, x3 and x4 and it can be represented by three nodes having two branches and in the first figure, in between x1 and x3 the transmittance is A, in between x2 and x3 transmittance is B, in between x3 and x4 transmittance is C. So this complete system can be represented by from x1 to x4 the transmittance is AC, from x2 to x4 the transmittance is BC. So intermediate node is eliminated, that is a mixed node can be eliminated by multiplying the transmittance of outgoing branch to the transmittance of all incoming branches to the mixed node. So here x3 is, that is mixed node x3 is eliminated and we are multiplying the transmittance A and C. Similarly we are multiplying the transmittance B and C and we are representing it as the figure shown in the second figure, okay. So next rule is a loop may be eliminated by writing the equations as the input and output node and rearranging the equations to find the ratio of output to input. The ratio gives the gain of the resultant branch and this rule can be explained by using a diagram. Here three nodes x1, x2 and x3 and it has transmittance A, B and C and we can see that B and C forms a closed loop because starting from the node x2 it will travels to node x3 and again it will goes to x2. So it is a closed loop, okay. So we can represent it by a single branch transmittance. We know that in the case of closed loop its transmittance will be B by 1 minus BC and we can multiply with A with the branch transmittance of loop. So we will get from x1 to x3 the branch transmittance will be AB by 1 minus BC, okay. So that is shown. First we will find out the loop transmittance as B by 1 minus BC, and we will then multiply that loop transmittance with transmittance A. So we will get AB by 1 minus BC. That is the branch transmittance from x1 to x3. And its proof is also given. In the proof it is given that x2 will be equal to AX1 plus CX3, right? At x2 AX1 is coming, also at x2 CX3 is also coming, and we know that x3 equal to B x2. We can put x2 value AX1 plus CX3 into equation for x3. So we will get x3 will be equal to B into, instead of x2 we are substituting AX1 plus CX3. So we will get x3 into 1 minus BC equal to AB into x1. So x3 by x1, that is the output to input equal to AB by 1 minus BC. That is the proof for this case. So, and this type of relationship we will be using for reducing the signal flow graph. So once you are asked to reduce the signal flow graph, you have to use all these rules, okay? These rules are very simple. There is no complexity in these rules, okay? You can simply use these equations in order to solve the signal flow graph. That's all about this signal flow graph algebra.